This is video number 3. It is a continuation of previous video. Today I am going to cover basic definitions like magnetic permeability mu r, susceptibility, magnetic moment, intensity, like that. These are the terms today I am going to discuss. Now, here magnetic permeability, the word itself indicates that permeability nothing but what? How many number of lines of force it permits. What it means? How many number of magnetic lines of force it permits. Suppose take a magnet. In the air medium there is lines of force are there. Same magnet you put in the water and you take another magnet, you can bring it near the water. Again, this is because of what? The interaction with the two magnets, it will start for moving. The number of lines of forces passing through the water medium, glass medium, or any cloth medium, it will be differs from one medium to what? Another medium and all that. Here, relative permittivity mu r equal to what? Mu divided by what? Mu naught. This is. That you said in the similar questions, similar one you studied in the electrostatics, in the previous second also you studied, that we are talking epsilon r equal to epsilon divided by what? Epsilon naught. This is mu nothing but what? Permeability of any given medium. It may be water, it may be glass, it may be copper, and this is what? Mu naught is the water, the permeability of the free space of vacuum. This value of mu naught, you know that it is 4 pi into 10 to the power of minus 7 Henry per meter. That is. This is one thing. Next is the value of susceptibility. This susceptibility, this is called as chi. Notation is what? Chi. It is a Greek letter. Pronounce it as a what? Chi. It is nothing but susceptibility. This susceptibility, the meaning of the susceptibility is what? It decides how easily the substance can be what? Magnetized. How easily the substance can be what? Magnetized. That is nothing but what? Susceptibility. It has no unit. It has no unit and all that. I will tell you, it's still that many cases. For example, this is the magnetic lines of force. These are magnetic lines of force. In which medium? In air medium. I will call it as a what? B naught. I will call it as a B naught. Next is, now I am considering one medium, that is what? One medium I can say. It may be copper, or it may be aluminium, or it may be platinum, whatever it may that is. Now what happens is, the lines of forces will be passes through this material, that is like this. Lines of forces are passing through it. And I will take another material, I will take it. Another material I will take it. Same magnetic field. External magnetic field is here also what it is. External magnetic field is what? H. Here also external magnetic field is what? H. In this case also external magnetic field is what? H. Here what you observe is the number of lines of force in this material is more. Here number of lines of force passing through this material is what? Less. That means this material, for example, it is nickel, cobalt, and this is what? Iron. This is another material. This is a paramagnetic material and all that. Here you see the number of lines of force passing through this material is more compared to what? This. That is what? Susceptibility. That means how easily the substance can be magnetized. How easily the substance can be what? Magnetized is nothing but what it is? Susceptibility, that is. And it has no unit and all that. Next is relation between susceptibility mu and all that. That is a one very interesting one, and also it's somewhat it is tough also. Here I will use the equation B total equal to B of internal or external plus of B of internal. What is B external? B external means applied magnetic field, magnetizing field, or I will call it as what? Magnetic intensity, I will call it as. B internal, nothing but what I will call it as a what I, it is called as intensity of magnetization. This is equal to, I will write here mu of what? B of what? Total. This is the mu is the what? Direct proportionality constant and all that. Here still you are getting the confusion. Of course, this point is clear. What is this? Applied magnetic field. Applied magnetic field or magnetizing field. It is just like about teacher, you can say that. Here, intensity of magnetization means for in all the materials, that is what the many atoms are there. Each atom is considered as a what? Atomic magnet. Atomic magnet. It is like this. Atomic magnet. When this material is now in the absence of external magnetic field, all magnetic dipoles are arranged in a what? Random fashion. They are arranged in a random fashion. When such kind of material is subjected to a external magnetic field or magnetizing field, now applying the magnetizing field H, now what happens? All these dipoles, it will be orient with respect to what? Magnetic field, with respect to applied magnetic field. Okay, with respect to applied magnetic field. Don't think that at a time all the dipoles will be oriented in this direction. That will be here, if the field is stronger, then definitely they will align in the direction of the what? Applied magnetic field. It is as good as I told you several times, if the teacher is very strong, then only what happens, the moment the teacher enters into the classroom, all students will be what? Polarized. All students will be oriented in one particular direction. That is. If the teacher is not so strong and all that, yeah, some of the students are misusing students are there. Here, even after entering the teacher is also, that means even in the presence of magnetic field also, the some students they will orient in this direction, in this direction, in this direction. That is nothing but what? Intent. Now, all these dipoles are oriented now in the direction of the what? Applied magnetic field. These dipoles will be contribute some magnetization, that is called as what? Intensity of magnetization. Intensity of magnetization. Here, remember, intensity of magnetization is directly proportional to what? H. This is the important, the concept here. What is that? I is directly proportional to what? H. I will write. Then you will ask question, what is that proportional constant? This proportional constant, I equal to chi into what? H. I will write. Now, I will rewrite this equation here. Now, B total equal to B of total equal to mu naught. I will write mu naught into bracket H plus of what? Chi into what? H. I will write. Which is the common factor here. This is equal to mu naught into bracket 1 plus chi into what? H. This is nothing but B of what? Total. Students, I can write B of total instead of writing that. Can I write B equal to total magnetic induction equal to mu naught into bracket 1 plus chi into what? H. Now, this is the important derivation. Still it is not completed. Now, I will rub it this portion. See? Yeah. Now, B equal to what? B equal to equal to mu naught into bracket 1 plus chi into what? H. If suppose only that vacuum is there, then what happens? I will write what? B naught I will write. This I will write here B naught equal to, at the time you see this factor is 0. There is no medium that is. There is no medium that is. When there is no medium, then I can write I equal to what? 0. When there is no medium, susceptibility equal to 0, then I is also what? 0. Then only this factor will be there here. I will write mu naught into what? H. Or mu naught equal to B naught divided by what? H. Next is, if there is a medium is there, then I will write B of medium equal to, this equation I will write mu of medium into what? H. You see, according to this equation I am writing. Here it is what? Air medium. Here it is what? Any medium is there. So that instead of writing B naught, I am writing what? B of medium. Instead of writing mu naught, I am writing of what? Mu of m of what? H. Now you see, B of m equal to mu naught, mu of medium into what? H. Now compare these two equations, you compare it. These two equations, you compare it. When you are comparing this, then what happens is, this is H is, now this is nothing but what? Here mu of medium equal to mu naught into bracket 1 plus of what? I think you can able to understand. This is the confusion here. This H, same. Then this mu is nothing but what? This here. Or I can write in this fashion. I can write now mu of m divided by what? Mu naught equal to, what is this? 1 plus of what? What this expression says is, the permeability of the medium, magnetic permeability of the medium, it is how many times it is stronger than the what? Air medium. You are comparing with respect to what? Air medium. That's why I will call it as what? Mu r equal to mu m divided by what? Mu naught. Just like what? Relative refractive index and all that. Here, can I write like this? Suppose mu naught is 1, of course it's not 1 here. And mu of medium equal to what? 30. What is the meaning of this is, the magnetic permeability of the medium is, it is 30 times, or else I will take 3, that is equal to what? 10. That means 10 times it is more, that is. This is the meaning of this. Okay, so normally you will get a 2 mark question here. Then derive the relation between the susceptibility and magnetic permeability, that is what? Mu r, that is they are asking. Here what is important is, this equation is important. I is directly proportional to what? H. Then I equal to what? Chi into what? H. This is the what? Proportionality constant. Then what I made is, with respect to this equation, for air medium, a medium, this quantity will be 0. There is no medium. That's why I am writing B naught equal to what? Mu naught into what? H. If you consider as a medium, then I will write B of medium equal to mu of medium into what? H. Here you see, compare it, this H, this H. So that this entire factor is nothing but what? Mu of medium equal to mu naught into bracket of what? 1 plus chi. Or else we can write in this fashion also, we can write it that. Okay, this is the equation for what? The relation between mu r and chi, that is. Next is the difference between what? Diamagnetic material, paramagnetic material, and what? Ferromagnetic materials and all that. Okay, first in diamagnetic material, first I'll discuss diamagnetic material, that is. In diamagnetic materials, you write properties of diamagnetic material. properties of diamagnetic materials. Properties of diamagnetic. Here the one important property of the diamagnetic material is all magnetic dipoles in the absence of external magnetic field. Of course, the net magnetic dipole moment is zero, no doubt, for all the materials. For all the materials, in the absence of external magnetic field, the magnetic dipole moment is zero. For all materials, it may be diamagnetic, it may be paramagnetic, or it may be water, ferromagnetic, and all that. And there are no atomic dipoles, you're right. There are no permanent electric dipoles. What is the meaning of this electric dipole? Dipole is nothing but what? One positive charge and another one is what? Negative charge. Both are separated by certain distance. There is nothing but dumbbell, that is. There is nothing but dipole. Very good example is hydrochloric acid. It is H plus and what? Cl minus. Very good example for this. But in some of the materials, what happens is, it is dielectric materials where there is a superposition of positive charge and also what? Negative charge. That is what? Positive charge and negative charge both are superimposed. When they are superimposed, that means dipole moment equal to what? Zero. But here, dipole moment equal to charge multiplied by what? Distance between the dipoles. Distance between this charge and this charge. It is Q into R is nothing but what? Dipole moment. But this dipole moment is existing in many of the molecules, that is paramagnetic, ferromagnetic, and all that. They have got the permanent electric dipole moment. But in case of dielectric, what happens? This factor is zero. That means equal to Q into 0 equal to what? J. That's why there are no permanent electric dipoles. This is the meaning of it. In case of what? Diamagnetic material. There are no permanent electric dipoles. Second, they are weakly attracted. They are weakly attracted by magnetic field. Or we can say that we can better not to write weakly. That is, they are better you write. They are repelled. They are better to say they are repelled by what? Magnetic field. Then certainly when they are repelled now, that means dipoles move from and atoms move from stronger to weaker magnetic field. Stronger to weaker magnetic field. Weaker magnetic field. Next point is, here important part. Here magnetic permeability μr is less than what? 1. You will ask question, why is less than 1? Just now I said that the relation μr equal to what? 1 plus of what? Kindness. This susceptibility value is there. Now it is a negative quantity. This value is negative and it is equal to what? 10 to the power of what? Very low quantity is there here. 10 to the power of minus 3 to what? 10 to the power of what? Minus 9 with negative sign here. The value of susceptibility is 10 to the power of minus 3 to what? 10 to the power of minus 9 negative sign. So that here the negative terms comes here. That's why the magnetic permeability μr is always lesser than 1 here. Next one is here they are strongly repelled, I said, no? So that whenever this material is placed, when this material is placed in the external magnetic field, this is the external magnetic field edge. When material is brought into the external magnetic field, this is the material, I will call it as a what? Diamagnetic. Now, all that is what? Magnetic lines of force, they are like this, strongly repelled. No magnetic lines of force are present inside this. No magnetic lines of force are present. They are completely repelled. It is like this. Very good example is your superconductor. That is, last time you studied superconductor. The condition for a superconductor is the material should be what? Perfectly what? Diamagnetic. Or diamagnetism is the essential condition for the superconductivity. Next is example. Which are the examples for this? Nitrogen is there. Water is there. Water. Sodium chloride. Copper. These are the examples for the what? Diamagnetic materials and composite. Here, very important question. Sometimes they ask you to write the difference between diamagnetic, paramagnetic and ferromagnetic. Here, there are no atomic dipoles. First one is there are no atomic dipoles. Then certainly the magnetic moment is what? Zero. And they are weakly what? Repelled in the external magnetic field. Or you can write repelled by the external magnetic field. And next one is the susceptibility is it is very low and it is of the order how much it is? Susceptibility. The chi is how much? 10 to the power of minus through 10 to the power of minus 9 with the negative sign and all that. The next is the relative permeability is less than what? 1. Why it is less than 1? I told you that is mu r equal to what? 1 plus of what? Here it is negative, that's why it is lesser than what? 1. And also when such kind of material is brought into the non-uniform magnetic field, they always move from stronger to weaker magnetic field. Next is properties of paramagnetic material. Here for the paramagnetic material and ferromagnetic materials, whatever discussed the properties for the diamagnetic, no, the same thing is there, but with opposite. Here, first one I told you, there are no atomic dipole magnetic, that is atomic dipoles, but no, they are having atomic dipoles. Susceptibility is what? Negative I told you, but their susceptibility is what? Positive. Then relative permeability mu r, I told you it is negative, but for the para and ferromagnetic material, it is what? Positive. And I told you for the diamagnetic, they are moving from the what? The stronger to what? Weaker. But these materials are moving from the what? Weaker to what? Stronger magnetic. So that comparison will be very, very easy for that. Then again, I will discuss it in the next video. I will discuss it.